So in this case, we are going to consider our recap of our financial mathematics. Remember, we had the basics of our financial mathematics in grade 10, working with the simple interest. You were working with the compound interest, where there is inflation, working with the interest rates, working with conditions of higher purchase, inflation, population growth, working with real life problems. Actually, that was what you had. And on that part, you were using the simple interest in your calculations and also the compound interest. So that is what we had, guys. And as a recap, we need to understand those basics. All right. We need to understand our basics as we are having our grade 11 mathematics, our financial mathematics, simple and compound, growth and decay is supposed to be covered. You also need the effects of different compounding and also to understand the timelines. We're gonna work on each and every section separately so that we do understand all aspects that are required. So the first part, let us consider the simple growth. So this is, I'm just going to be straightforward as we had this one before, a straight forward class that we're going to have. So that is when we are dealing with a simple growth where there is simple interest. Remember from our actually grade 9 mathematics, we had simple interest. Amount is equal to principal into 1 plus IN. If you still remember that, where there is a higher pay, when we are working with a higher purchase, when we are working with those inflation given a certain period of time. So when we are dealing with the growth, that's an increase in whatever that you are having, an increase. So you deposit money into a bank so that it can have an interest increase at the end of a certain period. Or we are referring to a population in a certain seat that you have or a certain place. The population, the increase of that population, an increase will be the growth. Then the decrease is the decay is a condition of a decrease. Wherever there is a decrease, you are dealing with what? A decay. That is when we are talking about depreciation, where there is a depreciation, there is a reduction in population. The population that we had, it has reduced, maybe due to a certain part that is affected. Maybe you're talking about the sickness, the disease that is affected a certain place. Then we have got death in that particular place. The decrease, that is a decay. Whereas the increase may be due to giving of birth. We have got an increase, a growth in population. So you use same formula, guys. What I'm trying to say is when you write the formula, A is equal to P into 1 plus IN, like you're dealing with the increase, and when you're dealing with a decrease, the question, when it is referring to the number of people, whatever that you are having, that is increased or decreased, these are the formulas that you are going to apply. So you take your A, which is the amount after, which is an increase, the final value. You take it as a final value. If it is the population, that will be your final population. If P is the principal, when you're talking about the money, which is the starting value, it means our P is going to be the starting value for the given population when you're dealing with population. So do not be confused to say, I'm writing A is equal to this, but I'm not dealing with money. I'm dealing with the number of people, all right? Just write the formula as long you know what exactly is represented on that formula, all right? So that is it. So as we saw, we've got two formulas there. One for an increase, which is a simple growth, which is a simple growth. So for a simple growth, we are going to have our formula as A is equal to P into 1 plus IN, which is the simplest formula that we can use. Remember, we can have a sort of presentation, so many ways of presenting, all right? But I'm going to explain what we are having in this case. So like I said, it's a simple growth, an increase, all right? Whereas we can have a simple decay. All right. So as for a simple decay, that's also it is referred to as the straight line method. The straight line method or the straight line depreciation. That is when they say using the straight line method or straight line depreciation, they are referring to a simple decay where our formula, this time we're going to have a negative. So it's P into 1 minus, this time we're going to subtract. So that's our formula this time for a decrease minus increase a plus. That is the condition. So we do understand A, like I said, representing what? The final value, the final amount, the accumulated amount. So here, since it can be for a population, we can be referring to the amount of money. So I'm just going to write this one as the final value, meaning to say the accumulated amount or the final amount that you are having when you talk about the amount. Is it population that you are referring to? All right. Whereas P is the initial value, the starting value. That's our starting or initial value. If you are referring to the money, that is our principal, the principal value. All right. That is principal value. Then we also have I there representing the interest. So this I there represents the interest that we are given. That is the interest rate. The interest rate. The interest rate. So take note. It's supposed to be a rate that you are referring, not to say just interest. And interest is an increase that you're having. But this one is the rate at which that amount is increasing or the rate at which that amount is decreasing, the one that you're having, that you started with, the way that it is decreasing or the way that it's going to increase. That's the interest rate. And we must have this one as a decimal. So we must have this one as a decimal, remember? So to have this one as a decimal, what are we going to do? The value that you're given, you must divide by 100%. So divide a percentage by what? By 100. So that's simply divide a percentage given by what? By 100. We must divide so that we have got a decimal. Then n representing what? The number of years. So that's the number of years. We are referring to the number of what? The number of years that you're given. So as you can see, guys, it's a straightforward part. Straightforward. Used whenever we're dealing with a simple condition, simple interest, when or they specify straight line depreciation, meaning a simple decay. So this is the same thing that we are going to have when we are dealing with the compound growth or decay, as we had those formulas before. All right. So here, let us just have number 2. That's for compound. So it can be compound growth, which is where there is an increase or a decay. just like what we saw previously uh, s- on our formulas. Wherever we are having a growth, all right, so let us have a compound growth. All right, so the first one is gonna be compound growth. Thus, there is an increase. So in this case, our amount is equal to P into what? So that's 1 plus I to the exponent of n. So we must have a bracket to the exponent of n, whereas when we are dealing with a decay, when it is a compound decay, which is also referred to as the reduction balance, which is the reducing balance, where there is a reduction, that's the reducing balance method. All right. So whenever they refer to the reducing balance method or reducing balance depreciation, there we are referring to a compound decay, meaning to say this time our formula is going to be having what? A negative, the decay, a decrease, that's a negative. So that's I to the exponent of n. So this is what we're going to have, with A representing the same thing, P representing the same, I representing the N is the same. So what we had here, still the same thing. So you must know the exact formula to use. Exact formula to use. And some can even work out here the principal value from this formula. We can, all right, we can make P the subject from this part that we had. If we, let's say, want to make P the subject, it was just going to be easy. We just say P is equal to, we divide by this bracket. So it's going to be amount over 1 plus IN. So as you can see, if it is for a simple interest, we can simply make P the subject of the formula in an easier way. But let's check here. For those who want to make P the subject of the formula direct, we can divide by the bracket, this one. All right. So meaning to say P is going to be A over what? This bracket, which is 1 plus I to the exponent of n. Let's go back to our exponents. 1 over x to the exponent of n simply means we can take this up and have what? A negative exponent. So if I have a over this, I can write this one on top with a negative exponent. So therefore, we can simply say P can be written as a times this bracket 1 plus I, but raised to the exponent of a negative. You can simply have this one as the subject of the formula from there. It is in your hands. Remember your exponents. This can be taken up. So if it is a over x to the exponent of negative n like this, it will be written as a times x to the exponent of negative n. There is something. All right. Here there is a 1, so you can't see it, but it is 1 times. That is what it means there. So we can rewrite, make P the subject of the formula. It is in your hands. All right. So without wasting time, guys, like I said, let us quickly go through our questions. Determine the value of 13,000 Rand after it has depreciated. Depreciated. So there is a depreciation, a reduction in terms of the value. This value is reducing. For how many years? For 3 years at 6% per annum. Then conditions are given on the straight line method on a reducing balance. All right. So what are we having? The starting value, your initial value, which is the principal value. All right. So that is what we are given. So we've got the P, which is 13,000 Rand. And it has depreciated. That's a reduction, negative. We talk about what? A reduction there. For 3 years, any the number of years. Remember, you said any represents what? The number of years. All right? at this percent per annum. So that's our interest rate, the interest rate, 6%. So that's 6 over 100, which is going to give us 0.06 per what per annum. All right. That is the condition. So we have this information. And the question was, we are supposed to determine the value of this after the value that is after. It is A. This one is what you started with, which is the principal. So the value after, it is A that you must determine, accumulated amount, the final amount, A, the final value after a certain value has been deposited for an increase. So they said using what? Straight line method or reducing balance on the other section. So when they say straight line, it is a what? A simple decay. They are referring to a simple decay. So 1.1, since it is a straight line method, that's a simple what? That's a simple decay that we're going to use there. All right. So our formula is A is equal to P into 1 minus IN. Remember our simple decay here. So this is what we have. So the amount after, the value after, that is our A. So A is equal to, just substitute, our P is there. That's 13,000 rand, 13,000 into 1 minus I as a decimal, 0.06 times the number of years, which is 3. All right. So this is you guys and your calculator. You can just use your calculator at once to simplify this value. All right, so that's 13,000. All right, then open a bracket, 1 minus, multiply this 0.06 times 3. Okay, like this. So that was going to give us 10,660 rand. This is the amount, 10,660. Just like that. That is how we can play around with our formulas. So we are going to refer to other sections of the class, especially on this reducing balance method. And okay, we're gonna see as we move on. So the reducing balance method, that is a condition when we are dealing with what? A compound decay, reducing balance. So our formula, all right, so that's A is equal to P into 1 minus I to the exponent of n. So just substitute. We have got everything, guys. 13,000 into 1 minus I as a decimal, 0.06 to the exponent of n, the number of years. All right. Then it is you and your calculator at this moment. All right. So let us have our calculator. So that is 13,000. All right, open the bracket, 1 minus 0.06. Then close the bracket to the exponent of 3. So we can have the exponent on this one, x to the exponent of, all right, this pattern of x to the exponent of this one. All right, so that is the one that you're going to need. So press that one. It gives us that exponent on top. So that's 3 is equal to. All right, so this is what we have. And since we are dealing with the money, we can round off to 2 decimal places, but also follow the instructions that you'll be given. But specifically to what? 2 decimal places. So it's going to be 0.59, or you can just shift, then go to the setup, fix your calculator to 2 decimal places. All right. So that is what we are going to have, which is 10,000 and 797. All right, then comma 59. This is what we have. To what? To 2 decimal places. So you follow the instruction that you're given. But when you are not given, round off your answers to what? To 2 decimal places. So this is how these questions are given, as you are supposed to be very careful on your simplification. Very, very careful. All right, let's see another question. We are given a farmer bought a tractor. All right, he bought a tractor. Then what is happening? 5 years later, it had a book value of 5 years later. So the question is, what is the book value when it is a condition like this? You buy a car, you buy a certain thing that depreciates as time goes on, meaning to say the original amount, all right, the original, which is our starting value, compared to the final value is going to be greater than the final value. Because it is reduced, the final value is less, that is going to be less than what we started with. So in actual sense, we are saying P will be greater than A, or in actual sense, the amount which is the final value is less than the principal. It will be less than the principal. What is this condition where the amount will be less than the principal? Which condition is it? It is a depreciation. Where there is an increase, amount is supposed to be greater than the principal. All right? But where we said decrease, just like the previous question, there was a decrease. The final value will be less than what you started with. So this is the condition of a book value. The amount, which is our final value, will be less than what you started with because of what? A depreciation. So that's the depreciated value. In this case, we are talking about a tractor. So we're saying that is the depreciated. All right. There is a depreciation there. That is the depreciated value of an asset. Let us just consider that of an asset. Okay. At any specified or any specific time, at any specified time. For an example, a car, it depreciates. You buy it today, tomorrow, as time goes on, it reduces the value, right? So this is the condition of a farmer that we have here got here. He bought a tractor. So meaning to say, when he bought it at a certain price, which is the original price, the starting value, which is the principal value, your starting value. He bought it at P, which we do not know in this case. But 5 years later, after a number of years, which is 5, we are told that the tractor that we are given can be sold at this value. The book value is this. Its value now, when you want to buy that tractor, it is at what? 168,345.22. All right. This is our A, the final, after 5 years, final value. Take note. So the question is to determine the original value, which we are not given, of the tractor if the annual rate of depreciation was 14% per annum. So that is divided by 100, remember, so that's going to be 0.14, all right? So that is what we had per annum. And the question was on 2.1, on straight line method. Remember, straight line method, that's our simple what? Our simple decay. And we said for a simple decay, A is equal to P into 1 minus IN. So what we need is P. And if it is like this, we can simply divide by the bracket 1 minus IN, divide by 1 minus IN both sides. So this can cancel your amount, your principal value can be determined, which is your original value. So that's amount, accumulated amount over what? 1 minus IN. So we're just going to substitute what we are given, in this case, our accumulated value, which is in this case, it's a condition of a depreciation. It is decreasing. All right. But that's our final value. In that case, we can understand each other. All right. So that's for 5,22, everything over 1 minus the interest rate, which is of that reduction, is 0,14 times the number of years n, which is what? Which is 5. So that was going to give us the original value, which is the principal, the one that he bought the car, the tractor initially before it reduced the value. So that's it. Put a fraction 168, 345, comma this 2, everything over 1 minus the product. You can open a bracket, you can multiply. It is up to you guys. 0,14 times. All right, there is 1 4 here times 5. All right, just make sure you insert all the values properly. All right, so this is what we're going to have. Remember, we fixed our calculator to 2 decimal places. It's already giving me my answer in 2 decimal places. All right, so that's going to be 5. All right, so it was actually bought at 561,150,73. All right, so you look, guys, but due to depreciation, look, now the tractor can be sold at this value, book value. So those are conditions that do happen to assets depreciate in terms of the value. Anyways, let us check when it is on a reducing balance method. That's 2.2. Reducing balance, remember, that's our compound decay. That's our compound decay, this one, remember. So A is equal to P into 1 minus I to the exponent of n. And I said we can make P the subject. When we divide, we saw that it can be written as A into 1 minus I to the exponent of negative n. All right, remember we made this one the subject of the formula here. So you can have it that way. It is up to you. Or you can just, guys, mathematics, it is in your hands. You can just divide like as it is. P is equal to, you take your A as it is over what? 1 minus I to the exponent of n as like this. Nothing is wrong with that. You insert your values. So P is equal to A as it is 168, 345, comma 22, everything over what? 1 minus I there, which is 0,14 to the exponent of n as positive as it is, which is to the exponent of 5. You get the same answer with someone who wrote it this way with a negative as you make it the subject, taking this on top. Still one and the same. So what is our A? We insert our values. All right, so let us take this one. So P is equal to, remember our A, that's 168, 345, comma 22 into 1 minus I there, which is 0,14 as a decimal. But this time we have a negative exponent. It is just because of the presentation that you want to use. It is in your hands. So that's to the exponent of what? Negative 5. So with this, we're going to obtain the same value of P, which in this case, that's our original value of 300. All right, so it was going to be 357,856,19 to 2 decimal places. You do the same thing on this presentation, that was going to give us the same answer in that case. So guys, this one, it is in your hands. You work out the way that you do understand. Do you want to make P the subject of the formula in this way, or you want to make it the subject of the formula in that way? Do not worry. So let's revise. Let us revise, guys, as many questions as we can. Work out as many questions as you can. Try to figure out which is the best formula. So on these ones, just have a recap, guys, of your grade 10 where there is an increase. We're not gonna talk much about that. We're just gonna refer to question papers later on. Like I said, later on we're gonna have question papers. And also for this issue of an increase, I'm going to talk about it, working with the different types of compounding, the effects of different compounding periods that we are given. So that is going to be our next class.